In this video, we will look at how to graph a logarithmic function from its rule and a table of values. Let's start with a review. The rule of a logarithmic function is f of x equals a times log base c of b times x minus h plus k. It is represented by a curve which approaches a vertical asymptote closer and closer on one of its extremities. The equation of the asymptote is x equals h. To find the value of h, you must analyze the part of the logarithm called the argument. Make sure that the coefficient of x corresponding to parameter b is factored out in the rule. When this is done, it is possible to identify h. The logarithmic function lies either to the right or left of the asymptote. It all depends on the sign of b. If b is positive, the curve lies to the right of the asymptote. If b is negative, it lies to the left. The first thing to do when looking for points belonging to the function is to determine the asymptote and then determine on what side the curve lies. Now let's do an example. Let's graph the logarithmic function whose rule is f of x equals 4 times log base 3 of x plus 2 plus 5. The first step is to sketch the vertical asymptote. To do this, we need the parameter h of the rule. Here, the coefficient of x is 1, so there's no need to factor out b. There is no minus sign before the 2. Instead, there is a plus sign. Therefore, h equals negative 2. The asymptote can be placed at x equals negative 2. For now, let's make a sketch. When there are many points, the axes can be scaled and the function can be graphed more accurately. The second step is to determine on which side of the curve is located. We found that b equals 1. Since it's positive, the curve lies to the right of the asymptote, so to the right of negative 2. Now, we can start building the table of values, choosing x values that are greater than negative 2. Let's start with x equals negative 1. Replace x with negative 1 in the rule and calculate. Start with the brackets, which gives 1. Now log base 3 of 1 needs to be calculated. This basically means asking, which exponent should you apply to get to 3 to get 1? The answer is 0. Remember that any base with an exponent of 0 is 1. You now have 4 times 0 plus 5, which is 5. The point negative 1, 5 can be placed on the graph. Continue with another x value. Let's take x equals 0. To find the y-intercept, calculate what is between the brackets, which gives you 2. Here, a change of base is required, since 2 is not a power of 3. You can use your calculator, which is in base 10. We get log base 10 of 2 divided by log base 10 of 3. Remember that when a logarithm is in base 10, the base does not have to be written. The calculator tells us it's about 0.63. You get 4 times 0.63 plus 5, which makes 7.52. Now we have the coordinates of a second point, 0 and 7.52. Place it on the graph. Let's pause here and examine what's happening to the graph. The 2 points are relatively close to each other. It would be interesting to choose a slightly larger x value. Let's pick x equals 7. Start by reducing what's inside the brackets. 7 plus 2 is 9. What's interesting here is that by choosing x equals 7, the argument of the logarithm becomes a power of 3. So no calculator needed. This basically means asking, which exponent should be given to 3 to get 9? The answer is 2. You now have 4 times 2 plus 5, which is 13. We now have the point 7, 13, and we can place it on our graph. With these 3 points, the curve of the function is becoming clearer. We could find more points to obtain a more accurate graph if desired. For example, the 0 of the function could be determined. This time, replace f of x with 0 and calculate the corresponding x value. Inverse operations are performed to isolate the logarithm. First, subtract 5 from both sides. This gives negative 5 equals 4 times log base 3 of x plus 2. Divide by 4, which gives negative 5 over 4, or negative 1.25. Now, to find the x value, switch to exponential form. Here, negative 1.25 is the exponent that is applied to 3 to x plus 2. Apply the exponent, which gives about 0.25. Isolate x by subtracting 2 from each side, which gives x equals about negative 1.75. We have a fourth point, negative 1.750, which is the 0 of the function. All that's left is to scale the graph. Use a scale of 1 unit for x and 2 units for y. The asymptote and our 4 points are placed on the Cartesian plane, then the curve is drawn. Remember that as you approach the asymptote, it should never touch it. That's it. The function is now graphed on a Cartesian plane. Hopefully this video has helped you to graph a logarithmic function from a table of values. Note that many other points could have been found to get a more accurate graph. It all depends on your needs. If you want to know how to find the rule of a logarithmic function, check out our videos on that.